eat stars. They erase time. And yet, without them, galaxies might never have formed. Are black holes our cosmic enemies, or the most misunderstood architects of the universe? Tonight, we fall past the event horizon to find out. Are black holes our friends, or our enemies? Before we pick sides, let's talk about what a black hole actually is. A black hole isn't just a thing. It's a place, a region of space so warped by gravity, not even light can escape. That's not poetic exaggeration. It's literal. If you cross a black hole's invisible edge, the event horizon, you're gone. Not crushed immediately, not disintegrated, just cut off from the rest of the universe. Forever. They begin as something familiar, a star. A massive star runs out of fuel, can't hold up its own weight, and collapses inward. If it's big enough, gravity doesn't stop at a white dwarf or a neutron star. It keeps going until the core is crushed into a single point, a singularity, where all the mass is concentrated in zero space. That's where our laws of physics break down. Around that point is the event horizon, the last moment you could ever escape. Once you're past it, nothing can come back. Not your spaceship, not your radio signals, not even time itself in the way we understand it. Somewhere out there, in a dark corner of the universe, two black holes are dancing. Not in the way we understand dance. This is no graceful waltz. This is a gravitational death spiral. Each of them is a collapsed star, the remnant of unimaginable violence. Each of them bends space and time so deeply that light itself can't escape. And yet, somehow, they found each other. They orbit, at first slowly, massive, invisible, circling in silence. But with each orbit, they get closer. Why? Because they're bleeding energy into the fabric of the universe. Their motion sends out ripples, gravitational waves, tiny distortions in space-time that race across the cosmos at the speed of light. And those ripples carry away momentum. So their orbit tightens. They spiral inward, faster, closer, louder not in sound, but in distortion, until eventually they collide, two monsters merging into one. The explosion releases more energy in a fraction of a second than all the stars in the visible universe combined, not in light, but in gravitational fury. And here's the part that bends your mind. We can hear that, not with ears, but with instruments. Get too close, and it's over. A black hole doesn't chase you. It doesn't attack. It just waits. So heavy, so dense, that falling toward it isn't a choice. It's physics. And once you cross the line, the event horizon, you're not just falling. You're being torn apart. Not metaphorically, literally. It's called spaghettification, a real scientific term, because the human body wouldn't be crushed all at once. Your feet would fall faster than your head. Your atoms would stretch into a string, a human-shaped thread, unraveling into nothing. But black holes don't just destroy people, they destroy stars. We've seen it. Massive stars drifting too close, their surfaces getting ripped away by gravity, spiraling into a glowing disk of death. It's called a tidal disruption event. The star doesn't explode. It's devoured. What's left is a brief flash of radiation, and then silence. Planets aren't even a challenge. No matter how ancient, how stable, how alive, they crumble under the forces. Even the bones of a solar system turn to dust. And if that's not the definition of an enemy, we're going to need a better one. And it's not just unlucky stars that get too close. Most galaxies, maybe even all of them, have a black hole sitting quietly at their center, not wandering, not devouring things constantly, just sitting there, massive, anchoring the entire structure. In our own galaxy, it's called Sagittarius A. It's about 4 million times the mass of our sun, and it's right in the middle of everything. The stars, the dust, the spiral arms, all orbiting around it. For years, we couldn't see it. Too much interference, too far away. But we could watch the stars near it, and they moved in tight, fast orbits. That's how we knew something invisible and unbelievably massive had to be there. And then in 2022, we finally saw it. An actual image taken by the Event Horizon Telescope. Not a clean photo, more like a glowing orange fog with a perfect dark center. That's the shadow, the point where light can't escape. The best picture we've ever taken of the black hole in our own galactic core. It doesn't move, it doesn't shine, but without it, our galaxy might not hold together at all. Which raises the question again. Are black holes just destroyers? Or are they also part of the reason anything exists at all? Time doesn't move the same near a black hole. Get close enough, and it slows down. Not like you're imagining it. Actually, physically, slows down. It's called gravitational time dilation. Predicted by Einstein, confirmed by observation. The stronger the gravity, the slower time passes relative to someone farther away. So if you hovered just outside the event horizon of a black hole, 1 hour for you could be years, or centuries for someone far away. To an outside observer, you'd look like you're frozen, stuck in slow motion, redshifting into darkness. But to you, you're falling, fast, normal speed, until you're gone. Inside the event horizon, time and space swap roles. You don't fall toward the center of the black hole. You fall into the future. Because the singularity becomes a moment in time you can't avoid, not a place you move through. Let that sink in. Near a black hole, space curves, light bends, and time itself warps. It's not just a location. It's a break in how reality works. For something that swallows stars, bends time, and traps light, a black hole seems like the closest thing to forever. But even they don't last. In 1974, Stephen Hawking made a radical prediction. Black holes can leak, not through cracks, but through quantum mechanics. It's called Hawking radiation. At the edge of the event horizon, tiny pairs of particles constantly flicker into existence. A quantum quirk of empty space. Usually, they cancel each other out and disappear. But near a black hole, sometimes one falls in and the other escapes. That escaping particle carries energy away. And that means the black hole loses mass. Slowly, very, very slowly. For big ones, like the one in the center of our galaxy, it would take longer than the age of the universe. But for small ones, it could happen fast. And when they die, it wouldn't be a quiet fade out. It would be a final burst, a sudden flash of energy as the last of its mass collapses into light. So yes, even black holes die. The universe doesn't leave anything untouched, not even its deepest shadows. Which brings us full circle. They destroy, they create, they hold, they disappear. Monsters or messengers, threats or teachers. They're strange, they're dangerous, and they're beautiful. Black holes stretch our understanding of time, space, and what's even possible. They terrify us because they show us where science ends and the unknown begins. But every time we study one, we get a little closer to that edge. And every time we ask questions, we grow. So maybe black holes are here to challenge us, not as friends, not as enemies, but as the cosmic test we have to pass to understand the universe itself. Black holes might not care about your support, but I do. Like and subscribe